Let's talk tunnels in time and space. Have you ever wished you could be somewhere else right now? Not in 10 hours on a plane, but in a snap? Imagine wanting to see the Great Barrier Reef, but you're stuck in Perth. That's a long, long way. You'd have to cross the entire continent, a real trek across the Nullarbor Plain. But what if you could just step through a door in your backyard in Perth and pop out seconds later, right on a sunny beach in Cairns? You could say good day to the fish before your breakfast toast even got cold. That, my friends, is the basic idea behind a wormhole. It's a cosmic shortcut, a secret tunnel through the very fabric of the universe. Think about it like this. Get a big sheet of paper and draw a dot on one side for Perth and a dot on the other for Cairns. To get from one to the other, a little ant would have to crawl all the way across the flat paper. But what if you could bend that paper? You could fold it over so the Perth dot is right on top of the Cairns dot. Then you could poke a pencil straight through both dots. Whammo! So where did this wild idea of cosmic tunnels come from? We need to meet a fella with some crazy hair and even crazier ideas. Albert Einstein. Einstein was a pretty clever bloke. He completely changed how we think about the universe with his theory of general relativity. Einstein realized that space and time are not separate things. They are woven together into a single, four-dimensional fabric called space-time. And here's the really brilliant bit. This space-time fabric isn't flat and rigid. Imagine placing a heavy bowling ball onto a trampoline. The trampoline mat dips and sags around the ball, right? Well, that's what the sun does to space-time. And planets like Earth don't orbit the sun because of some mysterious pulling force. They're simply rolling along the curve in space-time created by the sun. This idea of bendy space-time was revolutionary. The GPS in your phone or car has to account for the fact that time ticks slightly faster for the satellites in orbit than it does for us down here on Earth's surface. What exactly is a wormhole, according to the science? In theory, a wormhole has three main parts. You have two mouths and one throat. The mouths are the entry and exit points. One mouth could be right here, floating a few kilometers above Canberra. The other mouth could be trillions of kilometers away, orbiting a planet in another galaxy, say, Andromeda. You go in one mouth, zip through the throat, and pop out the other. If a wormhole was stable and traversable, the trip could be almost instantaneous. You'd step through the mouth here in our solar system and emerge from the other mouth in Andromeda. From your point of view, no time would have passed. One of the strangest things to think about is what you would see. Looking into a wormhole mouth might not be like looking into a tunnel at all. As you get closer, you realize you're not looking at a planet, but through a window. You could wave to an alien on the other side before you even decided to step through. It's a portal, a true window to the stars. But here's the catch, and it's a big one. According to Einstein's original maths, these wormholes are ridiculously unstable. They would snap shut in an instant. If we ever want to travel through one, we need to find a way to prop it open. Scientists have a name for this stuff, and it's called exotic matter. What makes this exotic matter so special? Well, its key feature is that it has negative mass or negative energy density. But exotic matter with negative mass would do the opposite. It would have anti-gravity. If you could somehow get your hands on a whole bunch of this exotic matter, you could use its anti-gravitational properties to line the throat of a wormhole. This negative energy would act like a cosmic jack, pushing the walls of the tunnel outwards. It would create a stable, traversable wormhole that you could, in theory, send a spaceship through without being instantly squashed into oblivion. That's a DIY project on a scale that makes building the Sydney Harbour Bridge look like playing with Lego. You'd need to harness the energy of an entire star just to get started. It's a technological feat that is so far beyond us it's almost magical. Let's just pretend for a moment. Let's say we've done it. We've cracked the exotic matter problem, and we've opened a stable wormhole network. The entire galaxy becomes our backyard. That star you see twinkling in the night sky, Kepler 186f, which is 500 light-years away and might have a planet a bit like Earth. That's no longer an impossible dream. It's a destination. We could send probes and then people to thousands of exoplanets. We could search for life, not by staring at blurry dots of light through telescopes, but by actually going there. We could land a rover on the surface, scoop up some soil, and see if anything wiggles. We could have mining outposts in one star system, farming colonies in another, and research stations in a third, all connected by the wormhole network. If we had colonies on other worlds, humanity would have an insurance policy. The survival of our species would no longer be tied to the fate of a single planet. Now, this is where things get really, really weird. According to Einstein's theories, wormholes don't just connect two different places in space. Because space and time are linked in space-time, a wormhole could also connect two different moments in time. All you'd have to do is take one mouth of a wormhole and send it on a very fast trip. If you took the exit mouth on a spaceship, flew it around near light speed for a year, and then brought it back, time for that mouth would have passed more slowly. Let's make this simple. Imagine you have a wormhole, and both mouths are in your living room in 2025. So now you have a doorway in your living room in 2030 that opens into that same living room back in 2026. You've just built a time machine. You could step through and have a chat with your younger self, but it also leads to some very tricky logical problems called paradoxes. What if you went back in time and accidentally prevented your own grandparents from meeting? If they never meet, your parents are never born. But if you were never born, how could you go back in time to stop them in the first place? While zipping across the galaxy and hopping through time sounds like a brilliant adventure, it's not all fun and games. A wormhole would be an incredibly extreme and dangerous environment. We have no idea what it would do to a spaceship or a person. It might emit huge amounts of radiation, frying any electronics and any living thing that tries to pass through. Then there's the problem of gravity. The tidal forces near the entrance could be immense. Near a wormhole, these forces could be so strong they would stretch your spaceship and you into a long, thin piece of spaghetti. It's a process scientists cheerfully call spaghettification. And what about the other end? You open a wormhole to what you think is a lovely Earth-like planet. But what if you get the address wrong? You might open a portal to the inside of a star, or into the middle of deep, empty space, billions of light years from any galaxy. You'd be more lost than a tourist in the outback without a map. There's also a more strategic danger. What if we weren't the only ones with this technology? If we can build wormholes, maybe an older, more advanced alien civilization can too. A wormhole is a two-way door. If we can use it to go to them, they can use it to come to us. Opening a wormhole could be like shouting "G'day" into the cosmic jungle. If we survived the dangers and mastered the technology, how would wormholes change us as a people, as a culture? For all of human history, we have been defined by our geography. But with wormholes, place becomes almost meaningless. You could live on a colony orbiting a red dwarf star, but commute to university in Sydney every day through a wormhole. You could have breakfast on Earth, lunch on Mars, and dinner on a moon of Jupiter. This would create a truly galactic human civilization. We would be united not by a shared patch of land, but by our shared humanity in the face of a vast universe. Art, music, and stories would be transformed. Imagine poetry inspired by the sight of a double sunset on a faraway world. Imagine symphonies composed to capture the sound of crystalline trees on a windswept alien planet. Our creative palette would expand from one world to thousands. We've traveled from Einstein's brain, through the weirdness of exotic matter, to the dangers and wonders of a galactic civilization. We've seen how wormholes could be the key to unlocking the universe. It's a technology so powerful it would change everything about what it means to be human. It would be the single greatest leap in our history, turning us from planetary inhabitants into true citizens of the cosmos. It's a future that is, for now, firmly in the realm of science fiction. But remember, science fiction has a funny habit of becoming science fact. The maths allows for wormholes, it sets out the rules. The universe has already shown us it's far stranger than we ever imagined. Who's to say that exotic matter and stable wormholes aren't out there, just waiting for us to find them? It requires us to keep asking questions, to keep exploring, and to keep pushing the boundaries of what we think is possible. So, as we stand here on our little planet, looking up at the endless sea of stars, we are left with the biggest questions of all. If the universe allows for something as strange as a wormhole, what other impossibilities are just waiting to be discovered?